Okay, this is the first of a set of videos on audio. So we're just going to go through a little bit of the basics to start with. So you do need to start with, have a general understanding of what each of the blocks in an audio systems do. So we've got an input source, sort of very, very low voltage. We then stick it through a preamplifier so that we can boost that signal sort of above the noise before we then start putting it through some sort of mixer to bring those two channels together. So at the moment that could be some voice, that could be some music, and then we'll bring them together into one part using a summing amplifier. We then might apply some tone control to it, so we might want to filter out some of the higher frequencies, but might want to boost some of the other frequencies, the lower frequencies. Power amplifier, so that we get the power ready for the loudspeaker. Okay, moving on past that, then we need to talk about maximum voltage transfer and maximum power transfer. Now with maximum voltage transfer, then if we think about it, some sort of AC signal, then inside one of the stages, that stage, whether it be the input source, will have an output resistance, and then that signal will then feed into another system that will have an input resistance. And this is sort of along the same lines as a Thevenin circuit. So if we're looking at maximum voltage transfer, and this goes along with potential divider, the potential divider, that if we've got looking for our signal there, we want the maximum signal there that we've got. So this Rin needs to be a lot bigger. So Rin of the next stage needs to be a lot bigger than the R out of the previous stage to get maximum voltage transfer. And we usually say roughly around about 10 times as big. Now where does it apply to? Well, it would apply to between the input source and the preamplifier, effectively every stage apart from power amplifier to loudspeaker. So we want maximum voltage transfer at all of these stages so that we transfer as much of the signal. That's why we're doing it. So we're transferring as much of the signal all the way through. When we're then looking at maximum maximum power transfer, then that's obviously a slightly different case. So let's just do a very, very quick calculation, just obviously to prove the point. So if we've got a signal there, and we've got, because it might be a while since you've done any of these, so we might have 100 millivolt peak signal that we've got. That's then being fed through a 100 ohm resistor, which is our output resistance, so that could be the output resistance of the microphone, and then our preamplifier, we might have a 1 kilo ohm resistance. So we want to know what's the voltage that we've got across there. Okay, so we can just work out what the voltage is using several methods. So I'm just going to use the quick formula. So the voltmeter is across the 1k, so 1k over 1k plus the 100 ohms times by our 100 millivolts, and I reckon that is 90.1 millivolts. So we've got a good transfer there, voltage there into the next stage. If we're looking at maximum power transfer, then we're looking for maximum power transfer, and that's usually it's usually there from the power amplifier to the loudspeaker. That's where we want maximum power transfer, and ultimately we want V and I to be at their maximum, at the largest values that we can have for them, because power is ultimately equals IV. Okay, so for this to happen, then the difference is going to be that our resistance out from the stage needs to be equal to the input resistance. Okay, right. Let's just do last little bit on bandwidth. So we know that bandwidth equals our gain bandwidth product divided by our gain. Now this formula is not on the form sheet, so it's certainly one that's worth remembering. Now if we have, say, a 741, if we've got a 741 op amp, that has a gain bandwidth product as stated by the manufacturers of different values, but we'll go for 1 megahertz. Okay, if we design an amplifier with a gain of 50, for example, then the bandwidth for that amplifier, gain bandwidth product over gain, so we've got 1 times 10 to the 6 divided by 50 gives me a bandwidth of 20 kilohertz. So therefore that would be good for voice. Okay, now if we say our overall audio system, we needed a gain of a gain of 2500, so we can create an amplifier circuit here. You know, we can have 2 amplifiers there, both with a gain of 50, okay, and that will maintain, if we do that with 741s, our bandwidth will equal 20 kilohertz in total, but the overall gain is going to be 50 times 50, which equals 2500. But if I was to do one big huge amplifier there of 2500, okay, my bandwidth now is going to be 1 times 10 to the 6 divided by 2500, and we're going to have a bandwidth of, I think it's 400 hertz. So that's why we go we can go for lots and lots of smaller amplifiers rather than one big one, so we can maintain our bandwidth of our signal going through. Okay, that's the end of this first video, and obviously we'll have a couple more to go. Hopefully that was all right.